seconds or so behind with lag time here, so between real time and what's going on. Whoops, sorry about that, guys. So yeah, give it a couple more minutes here. We've still got about a minute before the top of the hour, and we'll give it a minute or two after that for everybody to get in here. Hope everybody's doing good tonight. Feel free. Beth's gonna be. She's gonna be doing answering some questions in the live chat, and we'll probably take. I'll probably take some time at the end as well to go over some questions if you have any, or we can go back through something or whatever. But feel free to type in there, and Beth will see them, or I'll see them, or somebody will see them. I'm going to adjust my laptop. I have a laptop off here to my left, so I can see everything and see what the comments are and that kind of stuff. And then we can kind of go from there once those questions come in. So like I said, if you have questions, feel free to ask them during. But like I said, afterwards we will have some time to answer questions as well. Not really on any kind of a schedule this evening, being a Sunday evening, although I'm not going to try to ramble on and get off on tangents. All right, give it another minute or two. Just now 7 o'clock, so we'll give it a minute or two. Just kind of looking right now, this is the radar out of Goodland, Kansas. And you can see several severe thunderstorm warnings there in West Kansas with several nice storms going on there, some supercellular thunderstorms out into portions of western portions of Kansas, eastern Colorado this evening. So that's what's showing up on radar, so we'll give it another minute and we'll get going. Yep, lots of options. You can watch it from your computer, your iPhone, all kinds of good stuff. All right, well, I think we're going to go ahead and get started. This is something that can be replayed. I'll have to go back and edit this for some of you guys because if you're going back to rewatch it, because the first 15 minutes are just me messing around. So anyways, all right, so let's get started with this. And so this evening, we're going to be talking about RadarScope basics, understanding and using radar-based applications. We talked about in this, we're going to be talking about RadarScope. Now, there's a lot of different applications, and we'll show you a couple of those at the end. But this is going to be RadarScope. I know that a lot of you have started using RadarScope, and I've really liked it. I know that Q has been using RadarScope and has kind of become really, I don't know if I want to say obsessed, but he's really come to enjoy it. It is a very interesting application. It's great for meteorologists, storm chasers, weather enthusiasts. So RadarScope, I'm going to go ahead and say, if you're watching this and don't have it, if you want to, go ahead and download it. You can get it on Windows, you can get it on Mac, you can get it on iPhone, you can get it on Android. So, just go to its RadarScope. It's $9.99, one-time fee, can't beat it. So it's a great product, and that's what we're going to be talking about here this evening is RadarScope and how to use that, and as well as how to use some of those products. So the first thing, before we get too into this, I'm going to tell you, so if you're a meteorologist or a storm chaser watching this, I'm going to forewarn you, this is going to be very down to earth. It's going to be layman's terms. We're not going to get a whole lot into the science of how radar works necessarily, or how some of these products are derived, or anything like that. This is basically just showing you how to use RadarScope and some of the ways you can use that to better understand thunderstorms or whatever's showing up on radar in general. So it's going to be very simple. And perhaps if there's enough interest in this down the road in 2 or 3 weeks, if people would like an advanced course or would be more interested in thunderstorms, identifying different types of thunderstorms on radar as well as in the sky, that kind of stuff, maybe we can look into it. But today it's going to be pretty simple. It's going to be pretty down to earth. So, but I will talk initially here a little bit about how radar works. And so you can see in our little GIF here, you've got the radar dome out here, and you've got the radar spinning round and round. Initially, so this was with our initial radar system, the WSR-88D, it would send out one pulse, and that pulse would go, hit the droplets in the thunderstorm or whatever was in the atmosphere, and then that pulse would get put back to the radar, and then it would get shown on computer or whatever through the software as what we see as radar. However, now that was only a horizontal pulse, but now because of the advancement in Doppler radar and what is now what we call dual pole technology, not only is the radar beam going this way, but then it's also this way. So not only is it horizontal, but the beam becomes vertical, and so it allows us to measure particles or droplets in the atmosphere, and it gives us different products that have really, in a very exciting way, kind of advanced radar and advanced meteorology in the past several years, from hail detection to tornado detection and all these different things. So so basically radar is sending out that pulse in the vertical, and getting that return back, whatever that pulse is bouncing off of in the environment, and then it's sending one in the horizontal as well. And sometimes it's detecting bugs or dirt, or an airplane if it's low enough, or a UFO if there should be one. No. But so that's kind of the basis of how radar works. So we will get into a little bit of the science of it there, I guess. So first off, we're going to talk about the features. There's a lot of features. I say that with these radar-based apps. And we're going to be talking about RadarScope. Some of you guys probably won't use any of these. Some of you guys will. If you do, great. If you don't, great. There's a lot of you guys may just use the compile or the reflectivity, and that's fine. So let's go on over. So getting around the app. What is on the app here? So we're going to talk about setting locations. So like, we're going to talk about how you can put your home on there, your home location. You can put all kinds of different locations. We'll talk about finding radars, what you're adding layers, and I'll explain that in your settings, and we'll discuss a few other things as well. So the first thing, we'll talk about locations. So if you guys are interested in locations, and again, I'll try to kind of take this one slow because I think it's kind of an important part of this. Is setting a location. And I'm using some screenshots here because doing this on the phone is a little bit different than doing this on your laptop. So this is an iPhone. So we're looking at an iPhone. So if you want to set your location, the first thing you're going to do is go up to the top here, and I want to click on something here so I can have it. Is go up to the top and double click this area up here where like it'll say your radar site, Indianapolis, like mine's KIND. So real quick, you'll just kind of tap that. And when you do, it should kind of come up to this. It should come up radars and locations. And when when that comes up, you'll want to select locations. So that should be the next step. And then once you get there, obviously there's this plus, there's this add location. And you'll click on that add location. And so you click on that, and the next thing you get is this. So it'll say search for location. So the simplest thing to do here, so if you're sitting at home right now and you're like, I want to add my home to this. The simplest thing to do is go on over to the little arrow right here. This is a GPS marker. And you click on that arrow. And what that is going to do is it's going to use GPS to pinpoint your longitude, latitude. And that's going to come up. Let me go to the next slide. So that's going to come up, and it'll say your longitude, latitude, and it will pop it up there. And it'll come up, and this, instead of saying your address, it'll give your longitude, latitude. But initially, it should give you the option to rename that. Like, so if it said, for instance, if it pops up and says your longitude is 37.829, comma, negative 41,428, then it should give you the option to erase that and just put like home or house or residence or whatever you want to put. And then that'll be plotted onto the map. You just hit done and it's plotted onto the map. That's the way that should work in your phone. If you guys are listening, if you want to go to the comments, it would be really, really helpful for me to know how you guys are using RadarScope. Are you using it on Android? Are you using it on your iPhone? Especially if anybody's using it on desktop. That's pretty important. So I'm going to leave this slide here for a second and see if anybody wants to comment what kind of device they're using this on. So again, you'll go up here, you'll click this area up here where it shows your radar site up here at the top that's in highlighted. Go to locate, click on locations, add location, and then hit it for your house. You'll hit the GPS, and then it should give you the option to, if you want to keep the longitude, latitude, you can, but it should give you the option to rename it. Yeah, there is a desktop. I just saw that, and there is a desktop option, and it's $30 instead of $9.99. But you do get like a feature or two more than you do there. So that's kind of how you do that. That's locations. Now, the other thing you can do, I will tell you, is we have, for me, I have multiple locations. For someone with multiple locations, like say you wanted to add your brother's house or your mom's house or your kid's school or your place of work, whatever it may be, you can just go in and type the address, and it should have a search option, and then it'll pop up that address, just like the example here. And you can leave the address, or again, you can rename the address. So that's something else. So yeah, I'm not going to spend too much more time on this because we've been on there for a while. And I timed myself doing this earlier, and it took about an hour, so I don't want to go real long. But that's kind of your locations, that's going to be the simple, it's going to be the way you do it. All right, so layers and settings. So we'll talk about both of these because they're both pretty simple. So if you're going to do layers and settings, you want to change your layers and settings, you're going to go down here to this little gear, to that little thing right there, and click on it. And if we go on over, the first thing we're going to talk about is layers, because when you click on that, the very first thing that pops up is your layers option. What you should have what I would say you really should have on at all times are definitely warnings. You should have cities and highways on as well. Locations, I turn locations on and off because obviously we have clientele locations on there and I don't want all those posted all over the place. So mine get turned on and off. Your storm tracks for you guys, it may be, especially if you don't have a in-depth version or in-depth knowledge, of storm tracking. Those storm tracks may be very, very helpful for you to kind of track the storm. So I would recommend those be on if you don't have an in-depth or at least somewhat of a background in tracking storms. The other stuff, spotter reports, imping reports, you can turn those on and off. Sometimes especially during severe weather, they get so numerous that they kind of clutter things up. So sometimes I turn them on. Spotter locations, especially spotter locations, it'll look like a million red dots if you're tracking severe weather. And then lightning, if you have the pro subscription, that's great. I don't, but if you have that, I would say turn that on, that kind of stuff. So yeah, in Android, the Android, and I meant to cover some of that too. There's I think it's on the left-hand side of things if I read right. I kind of tried to study up here on this a little bit through the RadarScope website. All right, so there's the settings, or the layers, in your settings. If you go on over, so this will be, there's your layers, and your next button is settings. If you click on settings, again, you can change some of these. Your radar generally should be RadarScope, and then you would have RadarScope 6, and this is just standing for how many images, like if you loop it, how many images are loaded would be 6. So you should select that unless you have a data provider, but we won't really go into that. Your warnings, you can either go through RadarScope or Allison House. Both of those should work. We won't go into any of this, into your RadarScope spotter network. If you are in spotter network, you should probably know how to work that. Then you go down here to advanced. I would say for you guys, most of you should probably turn expert mode off, and then I keep my TDWRs on. If you're not familiar with those, basically what they are very they're short range radars basically, and so they only go out a few miles, but they're more for Indianapolis has a small one around the airport, so that way if something's coming in, they can see it a little bit better. I keep them on. Honestly, for a lot of you guys, it's probably not something you absolutely have to keep on, but it doesn't really hurt. I mean, it doesn't clog up your screen or anything like that. So that's kind of a personal preference. Really, a lot of this, honestly, a lot of your settings, probably whatever comes, unless you're more into depth with this app or into using radar, probably whatever your default settings are pretty good. Oh, okay, it's in the this is in the options menu in Android, not settings. Okay, yeah, I'm not real familiar with Android. I did try to read up on some of that. But it's a little different reading it and then trying to use it, so I apologize for that. But so that's your layers and settings, so that's something you should look at. So the next thing is storm tracks, and you're going to see this, and again, you can turn these on or off. So your storm tracks, this is what they look like. You've got, for instance, this is a thunderstorm, and you can see these lines, the little dots, and we'll talk about those in a second. Now, if you go up, and so say, this one's showing rotation. If you go up and click that, whoops, if I go up, just a second. There we go, and click that. You can see, so it's going to tell me, you can see these times out here, 9:39, 9:54, 10:09, 10:24. If I click that, that's showing me estimated arrival time from the storm track. So, say you were, down here in Mellon, or however you pronounce that. You can use these to kind of get an idea of when the storm is going to arrive, or at least the kind of the area it's tracking. With that being said, this is not perfect. So, for instance, say you had a tornado warning and you were tracking this tornado towards your house, and this storm track said, well, that's going to be there at 9:25 p.m. Don't wait till 9:24 to take cover, because there's a chance that it's going to be 5 to 10 minutes off. The storm could shift, it could cycle. There's a lot of things. This is just a general idea. Personally, I don't use these a lot, but obviously I have a pretty in-depth background with this. But for those who are just getting into this or don't have a real in-depth knowledge, the storm tracks are pretty good. I mean, they give you a general idea of when to expect. that. And also, if you look here, it's maybe kind of hard to see, but at the bottom this says east at 19 knots. So this is giving you the movement of the thunderstorm. And if you were to click this little eye, it would give you all kinds of more information, such as, meso strength, hail size, that kind of stuff, or at least radar estimated. So that's kind of your storm tracks. And here's the attributes for storms. So we'll start this off. So the first thing you're going to see is it kind of looks like a target. Basically, it's a circle, full circle with a circle around it. And you can kind of see it represented here on this. And so what this represents is hail. So if I were to click on this storm track, it would tell me what size hail radar is indicating. Again, radar is not 100%. So if it says 1.5 inches hail, that doesn't mean if you get under that, you'll necessarily get 1.5 inches hail. Sometimes it's larger, sometimes it's smaller. It's just using an algorithm for radar to try to give you an estimate of what that hail could be. So it'll give you that. So that's the first one. The second one here, you can kind of see right in this area, which we just kind of talked about this. You can see the arrows. This is indicating a mesocyclone, or basically rotation, a rotating thunderstorm. So this is indicating there's some kind of winds within the storm that are causing it to rotate. It does not mean there's a tornado. It just means that the storm is rotating. So that's important, especially as meteorologists, for us to know. The third is what we call a TVS, a tornado vortex signature. And if we take a look at the images here, basically what I've got is a composite image, and then we've got our storm relative velocity image, and we'll talk about those in a second. But what we're seeing, you can see down here, that's what the icon will look like. It has a little tornado in it. With this being said, this does not mean there is a tornado. This is a radar algorithm saying, okay, this according to the algorithm looks like it could produce a tornado, or should be producing a tornado. And this was indeed producing a tornado. You can kind of see the red lines, or the red polygon where the tornado warning was in place. And so if you're tracking a storm and this comes up, it's far more important, especially for you guys, for non-meteorologists, non-storm chasers, to be more concerned if the National Weather Service issues a tornado warning as opposed to the TVS, because that tornado warning is being issued by a meteorologist as opposed to a computer algorithm trying to detect if there is one or not. But that's what that means. That's a tornado vortex signature. So it's indicating some kind of rotation, strong rotation, that it would think could go on or is producing a tornado. So those are the three storm the storm tracks and the attributes associated with this. So let's go on over. I'm going to escape from this, and I'm sorry. Yeah, the camera, I just saw the camera's blocking the larger symbol that looks like a target logo. That's hail. So sorry about that. I just now read that comment. All right, so let's go on over to RadarScope. And we'll go on into this. We'll go into this. So I'll give you guys a second, because I know you're kind of lagging behind. If you guys want to switch over to the radar I'm using, you can. If you don't want to, you don't have to. But I'm just going to go into the radar and kind of explain to you guys how to find some things on there. So I'll give you guys a minute to get there. Let's see. What do I want to talk about first? All right, so the first thing I'm going to talk about here is obviously, so the first thing you're going to see if you're tracking severe weather, if you're watching this, I'll zoom out, and I'm using the Goodland, Kansas radar, KGLD. So it's out here in very northwestern Kansas. If you guys want to use that radar, if you don't, it's not necessarily overly important that you do. You can just kind of follow along on this, but for those that want to kind of be interactive and kind of play with radar, you can as we go along. So we'll zoom in here. So the first thing you're going to see here are the warnings. And so you're going to have several different type of warnings with RadarScope. You've got severe thunderstorm warnings, which is what these are. You're going to have tornado warnings, you're going to have flash flood warnings, and you're going to have, I think it's marine advisories, special marine advisories, and I don't know if they've added snow squall warnings yet, but that may be something, if they haven't, very soon to come, will be snow squall warnings. And so if you were in this area, so let's go down, say you were out ahead of this thunderstorm. If you want to access this warning, you can click on it and it'll come up severe thunderstorm warning or whatever the warning is. And if you click on the eye, go to the eye, it will give you the whole severe thunderstorm or tornado or flood, whatever the warning is. It will give you that statement from the National Weather Service, what counties that are for. You just, you can go through and read it. Yeah, yellow is severe thunderstorm, red is tornado, green is flash flood, and then like a brown tan is your marine warnings. Yeah, or is it teal? Maybe that's just my color deficit disorder kicking in there. Nonetheless, if you click on that eye, so we'll go back and do this again. So if you go back and click on the severe thunderstorm warning or whatever it may be, you click on that and it's going to give you the whole bulletin from the National Weather Service. Locations, timing, hazards. You can see hazards there. Tennis ball size hail and 60 mile per hour wind gusts. It's radar indicated. So it's going to give you the whole text. And so it's going to give you interesting. So, okay, purple is a snow squall. I didn't know if they added that or not just yet. So those are warnings. The other thing you can do with warnings here, and I'm going to pull up my phone, so if you see me looking down, that's why. So with warnings, the thing, if you go up on my computer, it's in a different place. But with warnings, if you're using an iPhone, if you look in the top right-hand corner just below where your battery is, right now mine, it's circled in red and it says 19. So if you click on that, and I'll click on this on my computer as well, it's going to give you a whole list of current warnings, no matter what they are. And so you can go down here, and if you see, like your top one, the top one right now is Lincoln County in Colorado. So if you were in Lincoln County, Colorado, you could see that and say and click it, and that would take you to that warning. So it's very nice. You can click on that if it's in your area, if you want to. So that's kind of what warnings look like. That's where we are with that. The other thing that's very easy to do, so let's go in and talk about this real quick. So the way you can select radar, there's probably more ways than this. But for selecting a radar, one thing you can do if you want to select a different radar, on your phone it looks just like this on your phone, but it's in the bottom. It's kind of on the bottom left-hand side. It looks like basically a radar. And if you click on that, it brings up all these different radars across the country. If you're out of the country, if you're up in Canada, if you're up in Alaska at the Iditarod, if you are in Australia, it doesn't matter. If there's radars, this radar application accesses them. And so if you want to change your radar, you can click on these. The easiest thing to do, though, if you are, so say you're somewhere where you're not normally, or you're at home or whatever, if you go down and click, if you go to the bottom left hand corner, and you can do this or you cannot do this right now, but if you go down and click on the GPS arrow in the bottom left hand corner on your phone, that will send you to your house. And not only that, well, maybe, let me see. Give me just a second here, guys. Maybe it doesn't do this anymore. I guess it doesn't. It used to, and maybe it's in the settings, but it used to actually, if you would click on that, not only would it take you to your current location, but then it would automatically load the closest radar, and that might be something that's in the settings. And then the other thing you can do if you're looking for radar is actually go in and go through radars, but that's kind of a hassle, especially if you don't know. Probably the easiest thing to do if you're on your phone is, click on your location and then click on the radar button up here, and then, for me, I would go select KIND, which is Indianapolis. But, if you live in, let's say St. Charles, Illinois, if you live out there, so you're out here, and your closest one's going to be KLOT, which is K-Lot or Romeoville in the Chicago area. So, it kind of give you an idea if you click on that where your closest one is once you load it up. Okay, Beth said location symbol will automatically choose the closest radar to your house. Goodness. Okay, so there are those two things. Just quickly, I'll go and discuss this. So if you go down and at the bottom of your radar here, you can see there is a color table. You can see where it goes from like black up to blue, green, yellow, red, orange, red, pink, etc. If you scroll along this with your thumb here, and I'll show you this on here too, if you scroll along this, it'll show you what the different intensities are. So if I go back out, I'll go back out to Goodland, Kansas. If you guys aren't there, don't worry about it right now. But you can see, so we're getting into some reds and some pink. So if I go out there, I can scroll over those and it'll show me the, this whatever intensity it is. So 64 dBzs or 50 dBzs or whatever they may be. It'll show me what those are. I can scroll over that. Personally, I think it's kind of a pain in the butt because I think, if I zoom in and I'm trying to differentiate, okay, is this 63 dBzs, or is this 60 or is this 68? The tool, if you use if you go to a pro tier, which is a higher, if you upgrade into RadarScope, or if you download the software on your computer, there's an inspector tool, which is very handy because then you can just use this and scroll over it and it'll show you wherever you're scrolling over what the intensity is. So 59 dBz, 62, 66, 50, etc., etc. So I find that very nice. I think, if I'm going down here and I'm trying to, especially when it comes to like velocities or winds, and I'm trying to is this 38 dBzs or is this 42 dBzs? It can be kind of tricky a little bit. And it's not super important in, like I said, in this kind of look, but when we get into velocities, it does become a bit more important there. All right, so let's see, what else haven't we talked about? So if we go up here, and I'll show you this, so if we go up and, just a second. If you go up here, now on your phone, this is going to be at the bottom, but for me it's at the top. So if you go and look at your phone, we were talking about the color table at the bottom. Just above that, you should have this. It should be set right now to, it says Super Res Reflectivity Tilt 1, and it has the time and elevation and stuff. It's going to look a lot like this right here, but it's just kind of at the bottom of your screen. So if you're going through this and you're using radar and you want to change your product, you click on that, so you can tap it, and then you just scroll down. You just scroll down and it's got all kinds of different products. We are not going to talk about all these products today because we would be here till midnight, but we're going to go through what I think could be the most helpful. So that's how you're going to select your products. It will say tilt beside them. I would not recommend changing the tilt. I would keep those tilts at tilt 1. The only reason you're really going to change those is if you were really close to a radar, or, I would say, for most of us here, we should probably just keep it at tilt 1 as you go through those. Let's see, is there anything here? Make sure I've covered most of this. If you are using this on computer, one other thing I will say on your PC that's kind of nice that you can't do on your phone is change the text size. So if you notice, like I go down here, notice up here Lexington, it's kind of small text. I can take it all the way to this text here and make it much, much bigger. And that's kind of nice. Now that's a little bit too big for my liking. But that's something you can do on your PC that you can't do on your phone, unless, I don't know if Android can do it or not. So a couple other things. So say you're on social media and for some reason you want to tweet an image or a GIF. Obviously, you can go in and click the screenshot button if you want to do it that way for a still image. If not, if you go down on your phone on the bottom, at least for Apple, yeah, that's what I'm getting ready to do. The app, if you go down to your Apple to the bottom, it looks like a little box with an arrow, which is the upload button. That if you're using PC, it's this right down here. It says share. But if you click on that, it'll say, it'll give you the option, where to share it: Facebook, Twitter, Instagram, etc., etc. Usually, what I do is click, and I don't know if you guys can see this, but I click on Save Image, and then I just share it from there. I'm a little bit, it takes some extra time, but I do that. Just for me, it's easier. If you're using PC, you click on that and it will come up like all your different, it'll come up a bunch of different stuff there. So that's how you share it. Oh my gosh, yeah, it seems like there's a lot of differences in Android and iPhone how this is working. All right, so the next thing is how to animate radar. So how to get it to move. So if you're using Apple, what you're going to go do is, let me pull this down, and hopefully you guys can see this. And if you go to the bottom in the middle, there's a play button, and this is pretty self-explanatory. But you can hit that play button, and it will animate the radar. And so, if I click that, you can see it'll animate the radar there. So it'll show which way this is moving. On PC, I haven't figured out how to do this yet. But the cool thing on here, and I'm going to switch over to, let me pull this. Give me just a second, guys. The kind of the neat thing that I like on the phone here, and I hope you guys can see this, is if I click play, instead of just tapping it to play, if I hold that, it will come up a little bar at the bottom, and it'll load those 6 images, and you can slide that bar back and forth and actually rock the radar image back and forth. So it kind of gives you a little bit better, if you're like, oh, I'm only seeing it one direction and I kind of want to see which way it's moving, maybe storm tracks aren't doing well, maybe you don't like them, whatever. You can rock that radar image back and forth and kind of get a good idea of a better idea of the movement. And I do find that pretty handy that you can kind of rock that back and forth. So that's an interesting feature that I really like as well. A couple other features on here, like I said, it has, we have the measuring tool if you're using PC. This is available on your phones as well, but like you said, you have to upgrade to, I don't know if it's Tier 1 or Tier 2 Pro. I think Tier 1 is like an extra $9.99 a year. Tier 2 is $9.99 every month, I believe is what it is. There's also dual panel, which I don't have, which enables you to look at 2 products at the same time. One thing all of them do come with is a drawing tool. I like to use this. If I'm sitting at my desktop and I'm bored, I might, just doodle with it. But I do like this. It allows us to draw on things, pinpoint things. I could say, here's where the hail could be, etc. So that's pretty handy. The other thing that I like is also distance. So you can go up here and it looks like a little circle. So you can go out here and it's a distance calculator, and you can go as far as you want from whatever point to whatever point. You just you click on that and then click on whatever point. Say we're trying to measure the say, let me zoom in on this real quick. For instance, say we wanted to measure the distance from the core of the thunderstorm to McCook. And so we click on that, and then we drag it out to McCook, and this would tell us it's 54.5 miles from the thunderstorm to McCook. So that's, it'll give you an idea of how far that thunderstorm is away. If you really want to do a little math and you're confident that your tracking skills are good, if this is moving east at 20 miles per hour and you're 40 miles away, you're getting the idea it's going to be there in roughly 2 hours. You can kind of do the math and kind of eliminate some of those storm tracks. But again, if that's more if you're confident in your tracking skills and know which way it's moving. So those are the main things on the app. So those are kind of the main things that we're looking at as far as layers and different stuff. There's a lot of different things on there, and the more you play with it, the more you'll probably see there's some other things that we're not going to get into. Alright, so let's go back to the slideshow here. I'm going to have to go through this because I always forget how to start from current slide. Alright, so the first thing we're going to start here. Oh yeah, I'm sorry about that. The distance tools, yeah. So if you go up here on the top on iPhone, if you go up here at the top, you just click on that, and all your distance tools, your drawing tools and stuff are at the top. You can collapse it into the top left-hand corner as well. I'm sorry, I didn't even think about that. So, all right. So let's talk about reflectivity or super res reflectivity. So this is pretty simple. This is just showing rainfall intensity, thunderstorm intensity, whatever you want to say. So super res reflectivity uses, we're using it to determine intensity. So how heavy is it raining? How heavy is it, how bad is the thunderstorm? We're using it, obviously, to track rain and thunderstorms. So if we're using that to see what the movement is, and we're using it, especially as meteorologists, and hopefully as you guys continue to learn, to determine what kind of storm it is. And while this isn't necessarily the one thing we use, it definitely helps. Is this a supercell? Is it a squall line? Is it an afternoon pop-up? What kind of thunderstorm is it? So we kind of use it for that as well. As meteorologists, storm chasers, weather enthusiasts, we can usually, if you have some background in meteorology, you can kind of look at different things, different features within this and say, oh, well, that's a supercell, or that's a squall. I mean, obviously, it's easy to tell if it's a squall line for us, but so kind of determining what kind of storm it is it's very useful for that. So super res reflectivity, or what we just call reflectivity, here's some guidelines. If it comes up, if you're seeing blue on the radar, that means it's very light rainfall. If you see 20 dBZs, that means it's green, or it's showing up green, that means light rainfall. No, the Portland image is not live. Some of these I screenshotted. A lot of these I screenshotted. Anything you see within the within this presentation itself, unless I have actual radar pulled up, anything in the presentation are screenshots. So just so everyone's aware and we're on the same page there. So like I said, 20 dBZs, you're seeing green. That's representative of light precipitation or light rain. You get into yellows, which is 30 dBZs. That's a more moderate rainfall. You get into oranges. You can see moderate to heavy rainfall, which is about 40 dBZs. You get into 50 dBZs. That's showing up red, which means heavy rainfall, sometimes heavy thunderstorms. It doesn't necessarily mean just because you're seeing red that there's heavy thunderstorms. I remember a few years ago, there was a weather station locally that was like, when you see red on radar, that's bad. And it's like, that's not necessarily indicative of a really bad thunderstorm. It's heavy rainfall. That doesn't mean, it's a nasty thunderstorm. So anyways, red can mean heavy thunderstorms, but it also can just mean very heavy rainfall. So don't get too caught up in that. And then 60 dBZs comes up as pink. That is intense to severe thunderstorms. And I put the little asterisk there with hail, while generally when you do start to see those pinks and some of those higher intensity colors, you're starting to potentially talk about hail. But again, that is not the case in all of this, in which case I would say these are more what you'd call guidelines than actual rules. So, don't just look at this and take this verbatim. This is just kind of an idea to kind of help you understand what each of these generally means, and there's a little bit of give within all of these as far as intensity and kind of what's included with those. So that's kind of your little primer there on reflectivity. This is an image I took the other day of radar in Indiana from Indianapolis. We were having a lot of thunderstorms, and I was putting this together, and I was like, oh, this is a good idea to show. And then I zoomed in. Like I said, super res reflectivity up here, it would be in the bottom on your iPhone. It would be on the bottom, but that's going to be your first setting. That's going to be your first, product. So it should probably, if you're just opening this, that should be what's up there. And if we zoom in, you can see some of the, different thunderstorms, some different features. We're not going to get really into features in this, maybe another time. You can see some pretty intense thunderstorms. Tipton down towards Arcadia, Daleville. A little story about this was Beth was actually driving through Daleville at the time and called me, and she's like, hey, can you pull up your radar? She's like, I just got into like some 1-inch hail and there's debris all over, and that storm was actually dying and collapsing on itself and produced hail in a downburst, and she just happened to be in the 5 to 10 minutes that it was occurring driving right under it. So that was pretty interesting. So I was like, I'm going to screen grab that. That's great. So anyways, that's kind of what reflectivity looks like. You can see, there's your color bar at the bottom. You can see all these different, the different colors. If you're interested in what these are, those are what we call outflow boundaries. Again, we're not going to get too much into that today. So your next thing is going to be precipitation depiction. So this is basically, in a wintertime scenario, you can go in and kind of indicate what what the precipitation type is. Some of the uses for this, used to determine rain, sleet, snow, that kind of stuff. I've seen meteorologists, use this for hail. Personally, I don't ever use it for hail. There's a lot of other things, a lot of other products, and one or two of them we'll cover that are much, much better, in my opinion, for hail, and can be a bit inaccurate, especially in the winter months, because it's an algorithm. It's an algorithm within the software that we use. And is reflectivity of the radar used? Yeah, you can catch birds and bats taking off. I see that Beth already answered that. I keep answering the same questions. But like I said, it can be a bit inaccurate when you're trying to determine rain, sleet, snow, and that's just because of the algorithm that it's used. So again, another screen grab. And you can see, this is pretty self-explanatory. I think most of us, if we watch the weather, we understand what these colors mean. But the blue is snow, the green is rain, and the pink, magenta, whatever you want to say, is sleet, freezing rain. You can see where it's representing out here, Sydney, Urbana, where there's kind of a mix of rain and snow. You've got kind of this mix up towards Portland, back out towards Marion, Indiana, and then a mix down here into southeastern Indiana. So it's kind of representing where that mix is occurring. As you get into, with this, the darker blues, for snow, and you can see the color table down here. The color table will be at the bottom on your iPhone, just like it always is, that you can scroll over. But obviously, as you get into the darker colors, darker blues, you're getting into heavier banding of snowfall. Same with the rain, same with the freezing rain, or sleet. So as you get into those darker colors with precipitation depiction, you're getting into the heavier precipitation. So it's really, precipitation depiction is pretty self-explanatory. If you're looking for that on here and you can't find it, if you go down here and click on, like down here where it says reflectivity and scroll down, it is the third one down on iPhone, at least. It says precipitation depiction. I don't know if you can see that right there, but that's where it's at there, and you can click on that. All right, so we're going to get into velocities, and these are a little bit more in depth than what we have just discussed. So we'll talk about super res velocity. If you guys want to follow along, you can, and you can go down and how you get there. Again, you click on your product there at the bottom, or if you're on NPC, it's there at the top left-hand corner, and you go down, and your next thing down, it's the fifth product down, it looks like, and it says Super Res Velocity, and you can click on that and it will pull up the velocities. So if you want to follow along doing that, if you just want to watch, again, that's fine. So Super Res Velocity, and some of this stuff I just pulled from a website. Basically, Doppler velocity products indicate storm motion toward or away from the radar. The velocity products in RadarScope use the Doppler effect to determine how fast the particles in the air are moving relative to the radar itself. Negative values, which are green in RadarScope and a lot of radars, indicate motion towards the radar, while positive values of red indicate motion away from the radar. They can be difficult to interpret without training and experience, but Doppler velocity products can be used to detect the overall movement of a storm as well as relative motion within the storm itself, such as rotation. Note that the radar can only detect the component of the velocity vector along the radar beam, so this isn't a full picture of the wind field, but it gives you a pretty good idea of where the storm is heading in the winds. And we're not going to get into velocity vectors along the radar beam. We won't go there. A little in depth. So what are we going to use super res velocity for? Well, we're going to use it for detecting how strong winds are within a storm, an outflow boundary, a hurricane, anything like that. This is very helpful when we're trying to detect how strong winds are with what we call a QLCS, or a quasi-linear convective system. So maybe you've probably not heard that, but squall line, a bow echo, a derecho, those are some very common terms that you can hear, you hear on TV or on Twitter or on social media. that a lot of people, meteorologists, storm chasers alike, will use. And then it is also used for detecting rotation within a thunderstorm. So if we're tracking a thunderstorm and it's rotating, it's giving us an idea that it could produce a tornado, or at least the thunderstorm is rotating itself. So we're using it for that. So first we'll talk about super res velocity in linear storms and those lines of storms. And I actually took this last night. So you can see pretty good line of thunderstorms here. This would be using reflectivity, and I'm going to show you the kind of how this looks in both. So we're looking at reflectivity, and you can see this is tracking out across eastern Illinois. Here's Kankakee, here's Champaign, there's Decatur, moving to the east and southeast. My luck, this got here last night, and it kind of died off, and it got to my house, and it just was not too exciting. But anyways, you can see there's the reflectivity, but this is velocity. So there's reflectivity, there's velocity. And you can see it showing up in the green. So we've got the greens. The radar is, I'm trying to think where exactly. Oh, the radar is right here. So the radar is down here in Lincoln, Illinois. And so you can see the greens, they're moving towards the radar. And then, of course, the reds, they're moving away from the radar. And there's your collar bar at the bottom. Now, I want to talk about this collar bar because it's very important, because the collars are moving toward, or this is depicting particles moving away or towards the radar. And so there's actually a value here, and I'm going to bring up my marker tool. There's actually a value, right, let's say right there, it's a rough idea, of 0. And so the middle portion of this is a value of 0, meaning there's nothing going on, there's no wind indicated. And then as you move to the right of this, you're getting winds moving away from the radar. And so these values are going to go up as you go to the right, and those are going to go up on the plus side. And then, on the is that right? The plus side, the negative side? Anyways, they're going to go up. And the same way on this side, they're going to go up as well as you go to that side. So don't be confused when you click on one and click on the other. And how do I erase this? There we go. When you scroll down one and it's like plus 50 and the other one's minus 50. So don't be confused. But you can see within this, there's some very strong winds. You can see where those reds are starting to turn into more of kind of like the bright reds and some of the tan collars. In fact, if we zoom in, you can see we've gone plus 82 mile per hour down into Decatur, Illinois. So that's what I thought. This is the plus side. This is the negative side. But you can see where those winds are very, very strong. With this being said, again, with a lot of radar products, you don't want to necessarily take them verbatim. This is not 100%. There's a lot of factors that go into this. But you can see this. The radar is suggesting near Decatur, there's 82 mile per hour winds. Now, with that being said, those radar beams are going out, and they are shooting because the Earth is curved. While they're shooting this way, you got to consider the Earth is curved. So as they continue to go out from the radar, they're actually going higher up into the environment because they're not curving with the Earth. They're staying in one thing, or they're staying at one level, but the Earth is starting to curve. So they're actually technically getting higher than in the atmosphere. And so as you get further out and further out from the radar, you start to see these values of some of these higher values, and you have to be careful sometimes because it's going to be more windy 4,000 feet above the atmosphere than it is, or above the surface, than it is at 10 feet at the surface because of friction and different things. So just be careful with that. But it does at least give you a general idea that there's going to be some strong winds with this, or there are strong winds with this. Obviously, you've got the yellow polygon, so there are severe thunderstorm warnings with this, indicating there's strong winds. So that is the velocity in linear storms. And then we take a look at super res velocity for rotation in tornadoes, or rotation/tornadoes. So I'm going to pull this up now. This is a this is going to be the same product. I say that this down here, the bottom image, is the same product. Again, if you have that dual panel mode, it's really useful. But you can see, so if we take a look again, this is reflectivity up here. You can see super res reflectivity, and you've got what we call supercell thunderstorm. And if you look, there's actually, it almost looks like a donut right here. And you can see there's kind of some lower values in the middle. This case, this tornado is wrapped up, and you can see that it's got a weaker value there in the middle. And if we go down, I'm going to erase this because I believe that I have markers on there. Yeah, there we go. So there's the rotation on reflectivity. And if you look down here, you can see there's those values moving towards the radar, moving away from the radar. And so we've got these winds that are interacting from different directions, and so the atmosphere is beginning to spin. So there's the rotation. In this case, it is a tornado, and you can see there's the red, again, very important for those not really too in-depth with using this, but that red polygon representing the tornado warning. So there was a tornado with us, and a tornado warning and a tornado with us down in DeMitt, Texas. So, all right, let me erase this real quick, and we'll continue. So that's one of the biggest things, for me. We use that a lot for really important indicating rotation. Here's another. This is a very close-up view, but I believe this is like west or west northwest Wisconsin, maybe, from the other night. But you can see where we've got rotation here. You can see there are the winds moving towards and the winds moving away, and so you've got rotation here. And like I said, I've used on the desktop, I've used the little measuring tool to see what the winds are here. Those aren't, those are just kind of what I like to use. I like to see how strong those winds are. All right, let's see. Just a second. All right. So that's kind of, and you can see there are tornado warning polygons with this as well for that rotation. So that's kind of a couple different ways we use velocity. The two main ways, now obviously this can be used in hurricanes. As hurricanes start to get closer to shore, you can click on radars and use this to detect winds around the eye or around the hurricane. That's kind of a cool thing to do when hurricane season is we're in hurricane season, but when there is a hurricane, you can do that. You can track gust fronts with this a little bit to some extent, that kind of stuff. Again, not really going to get into that today. All right, so storm totals. So rainfall totals, I like to use digital storm totals. And so digital storm total accumulation. And let me pull my phone back up here. So if, it looks like there's a tornado warning down here into Colorado. I'll have to take a look at that in a bit. All right, so if you're looking for storm totals, so maybe it rained at your house and for however long, and you want to check that, if you go in and you're going to go down, scroll down, precipitation, and the next one is digital, or the second one down is digital storm total accumulation. So basically, digital storm total accumulation is an estimate showing total accumulation for an event and may have bias applied. And we won't go too much into this. But so, this is pretty self-explanatory. Again, I've used the measuring tool for this because, again, it's kind of a pain to go down here, and you can see that how close some of these blues are and some of these reds are and different things in colors. So it's like, have I got 3¼ inches? Did I get 3.1 inches? And maybe that's not a big deal for some people, but I like to get it as close as I can. Nonetheless, you kind of get the idea there. Now, the thing I will say with this, there is the option to do a shorter range, like I think a 1 hour or 3 hour period of rainfall. Digital storm totals mean your total for the storm. And so what I mean by that is if it started raining at 9 a.m. and stopped raining at 11 a.m. and then didn't rain for a while, that would be your storm total. On the flip side of that, if it starts raining at 10 p.m. on a Friday night and doesn't stop until 7 p.m. on Saturday night, and you click on this, that's going to be your storm total. So it's basically the duration of the entire storm. And I know there's a period, I think, where that resets. To sit here and quote it, I'm not sure. Maybe somebody else on here knows what that is, but nonetheless, that's the only thing to keep in mind with this is depending on how much, when it rains, the time frame of that, and then how much of a break you get, that will sometimes reset. So just keep that in mind with that. All right, so this is something a little bit more in depth. This is vertically integrated liquid, or VIL. And I know this is there's some pretty big words in there. It's not as scary as it sounds. There's the best words. Those are the best words. So, so taking a look here, this is what the VIL looks like. Again, I'll pull up my phone. If you go down here to the bottom again where the products are and scroll down, it's going to be towards the bottom. It's actually going to say Other, and then it's going to be the first option under Other, digital vertically integrated liquid, and you click on that. And so that's going to be kind of what it looks like. If you were to do this now, here is, let me see if I can show you. Here is Western Kansas right now. There's some maxed out values there, so pretty impressive. Nonetheless, this is what it generally would look like. This is, again, not current radar. And then there's your digital vertically integrated liquid. So VIL uses, we use this in multiple things, indicating multi-cell versus supercell thunderstorms, detecting downbursts, detecting hail, and for today we're just going to use this to talk about hail detection, because I think that's probably the easiest. So here is the VIL. Again, this is that storm up near Delville, Indiana that I was telling you about earlier, and this was right as Beth was driving under it, and you can see some of those very high, pretty impressive readings out there just east and southeast of Daleville, where we're getting up into the pinks and the magentas, and so you can see those higher values there. So a couple things, and I might actually I think I got images, so I'm not going to exit out of here. So the higher values are indicating either more or larger hail, and I'm going to go on over to the next one. This is the next slide. So a couple things with this. So like I said, it is we do use this a lot to indicate hail within thunderstorms. And generally when you're looking at this collar bar, and maybe I will go back, when you're looking at this collar bar and you're starting to get up into the blues and the greens, sure, you can get some small hail as you get into that. A lot of times what I found is you get into like the blue-green collars there, a lot of times it's just heavy rainfall or big droplets. That seems to be the case more often than not, at least with my experience. Now, as you start to get up here into the yellows, into the oranges, that's when I generally, for me, with experience, that's when I start to see either more hail reports, or I personally, if it's coming over me, start to see small hail. And then as you start to get into like these reds, and especially into the reds and the pinks and the whites, that's when you're starting to see, pretty good chance of hail, large hail, a lot of hail, that kind of thing. We take a look at this, we'll go back to this, and I like this image because it's giving you an idea, it's kind of giving you a couple things to look at. So the first one, again, is reflectivity. And you can see where those, 67 dBzs, that's a very high value on reflectivity. And you can see on the same place, just a different product here. If we go on over to the digital VIL, you can see where that's white and that's maxed out in the same place. And so you can see that collaborates the highest intensity on reflectivity to the highest intensity on the VIL, indicating that there is hail. Now, the mistake I see made more than anything probably with this product is people see this and they see this big wide area that it's absolutely maxed out with the VIL, with maxed out on values there. And people are tweeting, softball-sized hail and all this different stuff. Sure, yeah, absolutely it could be. But with that being said, I've also seen a lot of instances where this maxes out white, and instead of getting softball-sized hail, you end up with a bunch of like quarter, $half golf ball-sized hail that in some instances like covers the ground and it almost looks like it snowed. So you could have one or two, you could have really big hail, but you can also just have a whole lot of hail. And obviously as meteorologists, we look at the environment, we look at different parameters, which kind of gives us a better idea or sense, okay, is this going to be large hail or is this just going to be a lot of hail? We kind of get that sense, but I just see a lot of people saying, well, this is just huge hail, and then it ends up not being hail. In this case, I don't know if anybody wants to take a guess. Is this huge hail or is this just a lot of hail? And, give you a second. But if we go on over and take a look at the storm reports, you can see this is not huge hail. It's 1.5 inches. It's a good size, but it's not softballs. It's not a baseball size hail. So it's not like they got real big hail. So I guess, if you're going to use this product, just, kind of keep it in the back of your mind. Just because it's maxed out does not mean you're going to have monster hail. And the best way, if you're not familiar, if you can't, if you don't analyze the atmosphere, the best way to determine that is to click on the warning in the National Weather Service. If you click on that warning text, it's going to tell you what to expect with it as well. All right, so the last product here is Enhanced Echo Tops. Let me get a drink. So the last product here is Enhanced Echo Tops. And so if you go down and you just click on that, if you're already to the VIL, you just go and the next product down is Enhanced Echo Tops. And again, it's under Other. And it's going to look like that. That's what the product's going to look a lot like. Again, this was taken in northern Wisconsin the other night. Northwestern Wisconsin, I guess, and then to eastern portions of Minnesota. You can see Iron Mountain there, Iron River, Ironwood. I'll call all the irons. So, all right, so Enhanced Echo Top uses. You can use them, increasing values can indicate updrafts, strong updrafts, rapid storm development. And I would recommend, if you're using these, especially for something like that, to animate them. Because really looking at them in real time, while it can give you an idea of how, it can kind of give you an idea of how strong the updraft is within that storm, you're not seeing the life cycle, and I'll talk about that in a second. Rapidly decreasing values can be associated with a dying storm and even strong downbursts. So we were talking about that storm in Daleville. That storm died, it collapsed on itself, and it produced a downburst locally and some hail. Very high echo tops, again, these are guidelines, these are not rules. Generally 35,000 feet plus are associated with stronger to severe storms. If you get into some extremely strong severe thunderstorms, 45,000, 50,000 feet is not uncommon. With that being said, there are what we call low top supercells, which can be 25,000 feet. So again, it comes down to knowing, kind of knowing and understanding meteorology in general. But again, like I said, generally you want to animate these and kind of see. So this is a still image. Again, I've used the measuring tool here from that same storm. You can see I've measured out. It's probably very hard to see, but topped out at 57,000 feet. That's extremely high. I don't know what the record is, but I don't know that I've ever seen anything much over 62,000 feet. So this is getting up there. This is a very tall storm that was in, I think this is northwestern Wisconsin the other day. Again, here is an animation of this. And you can see where we go, those storm tops start to blow up and they start to get high there and then they kind of die. So they blow up and they die. So just some uses, and I didn't put a PowerPoint in for these. But for me, let's say I'm storm chasing, if I'm waiting on thunderstorms to develop, this is a great tool so notice out here to the west where it's indicating like these blues and these very light colors. The colder colors, those are very low storm tops. So those are like storms rising a few thousand feet up into the atmosphere. So if I'm storm chasing or I'm looking at radar and I'm waiting on storms to initiate, this is a great product to look at because sometimes those storms won't start producing, those clouds, I should say at this point, don't start producing rainfall for a while, but you can start to see those as they go up through the atmosphere on this product. So it's a great tool to indicate thunderstorm development, cloud development. It's great because if those cloud tops are going from 20,000 feet or 25,000 feet and they've been that way, and then all of a sudden in 2 or 3 scans in 5, 10, 15 minutes, they've gone from 25,000 feet to 40, 45,000 plus feet, I know that thunderstorm is a good updraft. It's a rapidly developing thunderstorm, likely to become a severe thunderstorm if it's developing that quick. And again, on the same token, like this image, if the thunderstorm is if that thunderstorm is 45, 50,000 feet, and 2 or 3 scans later, or 10 or 15 minutes later, it's 30,000 feet, I know that thunderstorm is dying, and I know that it's weakening. So there's some really good uses for the echo tops that, I didn't really put those into the actual slideshow itself, but those are some general uses for that. So that's kind of, as far as products, that's going to be kind of what we talk about today. Again, and if there's enough interest and people feel like they're ready, I would be more than happy in a few weeks to go in and talk about more products, talk a little bit more on using this to identify different types of thunderstorms, and doing a little bit more of an advanced class with our advanced stream with this, and kind of kind of go into that a little bit more. Nonetheless, I don't want to leave out other radar-based apps because, frankly, we're not getting paid to promote RadarScope here, so I'm going to throw this in there. There's a few other apps. The newest one on the market here is called Radar Omega, and it's on Android and iOS. And so it's Radar Omega. They've got some cool stuff on there. I know there's a few different storm chasers that have been promoting that. So Radar Omega is one of them. I would say that's probably about the closest to RadarScope there is, if I were saying. The other one is called Weather Lab, and I actually have these last two. Weather Lab, there's not quite as many like products. There's some really cool little things you can do with it, like you can make the storm 3D and all this different stuff. I will say there's a lot of things. There's a lot of things in there that you might not use or might not really understand how to use. So I don't know, if you're a little bit more advanced with radar, maybe you could think about that. The other thing is called WeatherWall Mobile by Weather Weary, and I think this is only on iPhone. And I actually have this software as well. It really is a lot like RadarScope. With that being said, I don't think in my opinion, it's not as good. It has a lot of the same products, but it is missing some of the products, and the reflectivity and the velocities, in my opinion, are not quite as quality as what RadarScope is. Out of these three, I can't really sit here and say anything about Radar Omega because I've never used it. But if you're comparing the other two, I would say stick with RadarScope because it's really, really functional. And if you have a desktop, there's a ton of other desktop, radar applications out there. GR Level 3 is a great desktop radar application if you're ever looking. It's a little more pricey, but it's a great radar application. All right, so extra learning tools. So if you're really chomping at the bit and you want to learn more, this is a link, training.weather.gov, and you can see there's the full link. That is not just a RadarScope-based learning site. That is from the National Weather Service and NOAA, and so it's going to deal generally just with radar, how to use it, different product, all kinds of different stuff on there. But you can definitely learn. Don't shy away from it just because it's not using RadarScope. A lot of the things you're learning here for RadarScope are going to be a lot of the same if you're just using a regular radar. If you are like, I just want to stick with RadarScope, radarscope.app/guide/. That is actually what is called on their site RadarScope Academy. There are a lot of blogs and different stuff on there from people that that work at the company that own RadarScope, and there's a lot of different things on there that you can learn from that. So if you're wanting to learn, you can go browse all those blogs. There's a lot of different stuff on there, from simple to pretty advanced. All right, so thanks to Beth Carpenter, especially for the great story. That was a good story, and obviously thanks to Weather Intern Boo. He just inspires us every day. That's more what we're more thankful for him. But anyways, that's kind of all we have for this evening. Looks like we've got at least a couple people that are interested in a more advanced class here. Does anybody have any questions? And keep in mind, I'm on a bit of a delay here. If we have any questions, me or Beth will try to answer those. If not, we can be done. Boo's actually operating the computer. No, I'm just kidding. Nobody has any kind of questions? Anything like that? You can always reach out to us. Super res versus base reflectivity. Okay. And I'm just going to use this because I'm here. So super res, so the difference here becomes you're using, I guess, kind of like two different data. So super res is what we call level 2 data, and it is more of a raw data that comes in from the radars. It's more defined, it's more high res. Whereas your base reflectivity, so you can see, you can see the difference, and this is what we call level 3. This is level 3 data, which is not quite as high res. So there's base, there's super res. Again, base and super res. So you can see the super res is much, much better, and it's just a different data stream. And it's kind of the same thing with super res velocity. So there's super res velocity, and then here's like base velocity, and then there is storm relative velocity. And it's kind of cool. Kind of a cool story for that is, I remember when I first started storm chasing. When I first started storm chasing, it was like they were first coming out with mobile internet cards, and everybody thought, man, it would be so cool to use level 2 data because it's so much more, it's higher resolution. But because the mobile data, the data speeds were so slow, you couldn't. It would take forever to load. And RadarScope was actually the first to make level 2 data into an app and into a radar program that allowed you to really download this on the go and on the fly, and that was huge for RadarScope. That kind of put them ahead of a lot of the competition, as far, especially mobile radar, but radar apps in general, whether it was PC or whether it was on your phone or tablet. But yeah, it's a difference in your data streams. One's a little bit more high res than the other, and so your super res is going to be much better. Any more questions? Oh, good. I'm glad that hopefully this was helpful for everybody. Yeah, basically that's how it goes. The weather isn't exciting enough, and so we have to go pursue it. And that's pretty much it. That's how it goes. We go somewhere where the weather is exciting, where there is severe storms. Unfortunately, not too much has been done the past few years for storm chasing. It's been pretty quiet, but yeah, feel free to if you have more questions after we're done, to tweet us, like Beth said there, at TDSWX, at Met Cooper, at BCarpo1. Feel free. We'll try to answer them if we can. If we can't, we'll make something up. No, I'm just kidding. Just kidding. All right, I'll give you a couple more minutes for any more questions, and then it's been about an hour and 15 minutes, so I don't want to take too much. Yeah, so my radar, so the big difference, I haven't used my radar a whole lot. My radar is, I believe, now I think you can actually do the single site radar. So this is single site radar, meaning I click on this and I go to a single site. I go to one radar. Whereas my radar, I think it does have that option, but if you're using the free version of it, it's what we call a composite radar. So basically it's taking all the radars across the United States, and it's basically, in layman's terms, it's blending them together. that's blending all those radars together to create one image, and so it's not as fine scale. It's more broad. And composite radars do have their place. I mean, there's some really good things that you can do with composite radars. But, in general, especially when you're tracking tornadoes, things like that, or trying to find some, more small scale features on thunderstorms, it's not going to be nearly, not even close to as high resolution as a single site radar is. So that's the big difference between my radar and RadarScope or Radar Omega or whatever, single site radar software you're using. Any more questions? Trying to see if there's anything cool going on out here on radar, but I mean, I guess there is, but there's no, just some thunderstorm warnings going on. All right, well, I think that's probably about it, and so we'll kind of leave it at that. Again, if you have questions, feel free to reach out. It might be something here in a week or two that I might post a poll. Make sure to follow me and Beth on Twitter as well if you haven't already. I might, in a week or two, post a poll and just be like, hey, did you enjoy the stream? Would you be interested in a more advanced radar course? And we'll see how that poll goes. That we might do something like that. So anyways, that's all for this evening. Everybody have a great rest of your weekend and a good week, and stay healthy, and maybe we'll talk to you again in a few weeks.